The duty officer uses this viewer every day to maintain situational awareness. Being aware of planned events, such as the next college basketball game where thousands of attendees will be on hand, is helpful in assessing if extra resources are needed to respond to an event. Having access to critical information systems, such as computer-aided dispatch, enhances situational awareness. As the duty officer examines these high-priority CAD incidents, the person can see that the day has changed dramatically. The officer can see that there are concentrations of reports of a train derailment in this area. A police officer has communicated by radio to confirm that a rail tanker car carrying chlorine has been breached and is leaking. This incident will now get logged into the crisis management system. The EOC will be activated to its highest level given the magnitude of this event, and it will fill up with lots of people who will all be coordinated through the use of this viewer. After this event happens, there are 3 things that the duty officer needs to do immediately: determine the affected area, make decisions to reduce the effects, and communicate actions taken to the appropriate officials. Using the emergency response guide, the officer can quickly characterize the impact. The material type is known from the police officer, and the wind direction has automatically been populated from the closest weather station. By clicking a point on the map, the duty officer can quickly characterize the impact without overcomplicating. The initial isolation zone is in pink, and the protective action zone is in red. These zones have been overlaid with both population and critical infrastructure. This is actionable information created by the GIS on the fly. The number of people living here and their age structure helps the EOC determine how many shelters to open. The report of critical infrastructure shows what's affected and what will likely be shut down. This footprint will be used by the mass notification system and leverage the 911 database to tell people living and working in the affected area what to do to remain safe. So these tools have provided answers to the questions who's affected and what's affected. Right from the beginning, the duty officer has access to actionable information. For the next step, make decisions to reduce the effects. The hazard modeler has run a more refined plume using Aloha. It's been added to the viewer here. Additionally, the plume's been buffered by a mile to determine the hot zone. Roadblocks have been set up around the perimeter to keep people out of the area. Additionally, given the demographic information, shelters have been set up to give displaced people a place to go. Here we see their location on the map outside of harm's way. So this completes the second step. Now actions can be communicated to the appropriate officials and department heads by giving them access to this viewer through a secure login or printing a map, thus completing the third step. Next, let's talk about supporting incident management requirements. The Incident Command Team has communicated and documented their actions using mobile GIS. 2 divisions have been set up to maintain the perimeter, and an incident command post and a staging area have been established in a large parking lot. This information has already been synchronized and is available here in the viewer in the EOC. Now the EOC can quickly find resources that incident command teams need to do their jobs. By simply clicking a point on the map, the closest logistics resource can be found, such as a mobile feeding kitchen. Here's the answer to that question. Axco Industries is the closest provider for this resource. The spreadsheet of resources has just become actionable information and helped solve a problem. Next, let's talk about damage assessment. Here's the area where one of the teams is working. Damage assessment teams in the field use mobile GIS to do their work. They have access to GIS data on their mobile device. They can collect damage assessment information for this incident in a standardized way and when the work is done, they can synchronize these changes and post these updates back to the EOC. Now back in the EOC, the damage assessment report can be quickly generated based on work of teams in the field. Now let's take a step back and summarize what you've seen today. It was a long day in the EOC. The train derailment scenario could have been a lot worse. The strong data management strategy enabled people to get information when and where they needed it. The vulnerability assessment helped us better target our limited resources. Field operations benefited from the use of mobile GIS. The damage assessment was done very quickly. And overall, the response to this event was better coordinated with our situational awareness viewer.